So we're going to start on page 83 in your ISN because we're going to go back and do some stuff we didn't do with the calculator, and I believe this is what I actually want to do is on the back of the first sheet of paper. Yeah, okay. So we did all these questions when we did this by hand, which that's what was expected of us. But as with anything, we should be able to do this by hand without a calculator and with a calculator. And if this was truly a calculator question, it most likely wouldn't look exactly like this. So we're going to look at D. Now, if I had a calculator, we could do exactly what we did and then type that in, but that's not what we're going for here. We're going to pretend like this stuff along the way is not something necessarily that, well, even if we could, we don't have to. If they're telling us this is a calculator question and you can do it all on the calculator, you don't want to go through that in case you use the wrong rules. Does that make sense to you? All right, so if I want to start from the very beginning, so looking up here, from the very beginning here, they give me this, and I want to solve that using my calculator. I need a doorbell, I think, because I can't. Thank you. They tried to nail you 3 times in a row today? That was not nice. Okay. So if I have it with a calculator, I'm not going to do pretty much anything that I have written in purple there. But on the calculator, like, how would I do that without doing the steps that I have written down? What screen would I need to go to? If I want to know when does this equal this? If you're looking for where 2 things are equal, what are we normally looking for? The intersection. So which screen do I want to go to? The graph. Okay, so let's turn on our calculators. You're on the black screen, 1 for new, say no, and, well, maybe, sorry, mine doesn't always like what I'm going to do. And then we're going to add a graph, okay? So now that I'm going to do that, what am I going to type in to F1? Because I can't type that whole thing, right? Because there's an equal sign. So what do I type? Okay, so we'll do the natural log, which is under the E key. Natural log of x minus the natural log of 3. Where does the 2 go? In F2. Okay, so now when you're here, I could arrow down to get to F2, but what I do almost every time, even though I know I could just arrow down, is I hit enter just kind of out of instinct or whatever. And so now how do I get back to put something in F2? Tab. So in F2, I'm going to put the right-hand side of the equal sign, which was just 2. Okay, we good with that? Left hand of the equal sign in F1, right hand in F2, or vice versa. It really doesn't matter, but one side in each one. So now, are these going to intersect? Yeah, because as x gets bigger, doesn't y continue to get bigger? So clearly they're going to intersect somewhere. I can't see it. In order to do the next part, I need to be able to see it. So what do I need to do? My window, right? So when I go to window settings, I don't think I need the negatives on the x's. I'm going to go with 0. The x goes to 10 right now. We need to change that. We don't want to go insane and be like a million or anything, but what do you want to try there? Somebody give me a number. You whispered something. Now you have to say it out loud. 50? Okay, go with 50. I'll just tell you, last period somebody said 30. Y'all said 50. Let's just see what happens. Does that work? Absolutely. Because really all we have to do is be able to see it. You okay with that? All right. Now, I can see it. That's great. How do I figure out what that intersection point actually is? Menu. Then what? 6. Analyze graph. What am I doing? 4. So now that you're here, am I okay on where I am right now? No, I need to be on the left-hand side. Then I can click it. It does. I figured out how to do it. I figured out I can't do it like I have to. The board is different, and it's just weird. So there's my intersection. Okay. Now, we're going to just do some more calculator practicing because we don't use it a ton. Let's store that x value. Let me remind you how to store. You're going to get the little hand over it, and it's just going to hover. See the little hand right there? And at one point, I was trying to get you to grab it and stuff because there's other ways to do it, and I can't do most of those things up here. But once you're here, and it's just hovering there, You're going to hit the variable key, which is above 9, 1 for store variable, X, and enter, or whatever you want to call it. And then it's bolded, and when it's bolded, you know that you have stored it somewhere. Okay? Now, we wouldn't necessarily have to do this next part, but I want you to just because we're going to check some stuff. We're going to add a page, so Control Doc, and we're going to add a calculator. And then just hit X and enter, and that's the same number we just had, right? On the paper, when we did it by hand, we got, I don't even remember now, 3e squared. So let's see what that is. 3e squared, exact same number, because it's the exact same answer, right? It was 2 different ways of doing it, okay? I just wanted you to see that. We good on that? How did I save X? Okay. Let's go back to the calculator. Go back to the graph is what I meant. That's okay. So you're going to hover to where you see that right there. Well, notice now that mine is stored before I take it any farther. When I hover, it says it's linked in X. That way, if you forget what you put where, it'll tell you right there. Once you do that, then you just hit the variable key, 1 for store variable, and then X or whatever you want to call it. Everybody else good? Okay. All right. So then the next thing I want to look at is page 85. And on page 85, we are going to look at number 2. And I also want to restate something about this one. So we did it in purple initially, and then I did it in pink, and things came out a little bit different, right? But they have the same value. And remember that if it's a multiple choice question and you get either one of these, you would need to know how to put it in the other form just in case they don't match. But also to err on the side of caution, we don't want to leave fractions in there when we can actually change them like we did, okay? Until further notice, that's what we're going to go with. It's good skills to have. You have to have the skills anyway. But instead of doing all this on either one of them, we could have done this on the calculator. We were supposed to do it the way we did it. Let me just put it that way. But we could have a calculator question that's similar to this, and I'm just using these. So we've got g of x equals 8 times e to the 3x minus e, and we want to solve for when g of x equals 3e for the values of x. So we're going to do that basically the same way we just did. We're going to type in g of x. So let's go back to our calculator, hit the on button, 1 for new, say no, and let's add a graph. So we're going to type in 8e to the 3x minus, minus e. Now, when I hit the e button, a little thing pops up for an exponent, but I just want e, so what do I put there? 1. Okay. Then what goes in F2? 3e, right? Because that's what I want it's equal to. So in F2, I can do 3e to the first. I'm going to hit enter. We typed in 2, we see 1. Last time we typed in 2, we saw 2. We didn't see where they intersected, but we kind of knew where to go, right? Here, I don't really know which way to go. Do you? For sure? Are you like super confident on what to do by just looking at it? Maybe, maybe not. So here's another option that's a very limited option, and I want you to watch what I'm doing, okay? When I go to menu, I know I need to change my window. I'm going to zoom out, okay? Now, last period when I did this, my little magnifying glass was way down here. So let's just pretend like it's still down here. Here's a problem with zooming in and out. When I do that, and then I have to hit enter, because that was the center of my zoom, that helped me none, right? What I really want, now if you get your zooms all messed up or your windows all messed up, here's how you get back without starting from scratch. You go menu, window, and 5 is zoom standard. That gets you back where you started from, okay? So if you are going to zoom in or out, so if we go to menu, 4, we're going to zoom out, but make sure your little magnifying glass, unless you know you want it to be somewhere else, is close to 0, 0. It doesn't have to be exact. But if that is the center of my zoom, then when I zoom out, then I can kind of see all around. Does that make sense to you? So that's one kind of bad thing about zoom in and out. Sometimes it works nicely for you. Sometimes you need your window to be certain things, but here we really had no idea. I can see where they intersect. That's really all I care about right now. So you find the intersection and store x. Okay, I'll give you a minute to do that without me walking you through it. Make sure you can get through all those steps. So if you did everything correctly, you should get 0.102284. Yes? Anybody having any issues pushing buttons or storing or doing anything? We're all good? And if you want to type it in and check the value, you can, but I can tell you it's the same thing. All right, so that was just a little bit of calculator practice. We good right now? All right, so just flip them upside down. Grab the notes that you grabbed when you came in. And we're going to go there. Going on page 87 when we're done. Okie dokie. So we have this is logarithmic function, context, and data modeling, meaning we're getting into more of the real world stuff, right? We figured out how to do all these things, and now we're going to look at some things where we have to write equations and where logs make the most sense. Alrighty, so this says, the average salary for a church pastor across the U.S. increases as the size of the church increases, right? So this function is an increasing function. As x gets bigger, y gets bigger. The graph above shows the average pastor salaries for various church sizes. We can clearly see a pattern in the data, but the models we have used previously are not appropriate. So models we've used, I'm marking it out. Models we've used previously are not appropriate, meaning that in the past, we used linear, clearly not linear. We used quadratic, not quadratic. What else did we do? We did exponential, not exponential. I mean, it looks like something we're familiar with. What does it look like? Logarithmic, okay? And so it says that should say the graph. The graph, not the grow, above displays a large rate of change initially. So we got a large rate of change initially, but as the church size increases, we see that the rate of change gradually decreases. So this is increasing at a decreasing rate because it is concave down, right? So it increases very quickly, and then it kind of slows down. It probably tapers off at some point. The data above appears to be logarithmic, just like we already said, right? So just as we've seen with other types of functions, linear, quadratic, exponential, many real-world scenarios follow a logarithmic pattern. Outside the salary data in the graph above, logarithmic patterns are found in the way we measure. So logarithmic patterns, we do earthquakes, sound, acidity, and many other contexts. As a result, we have a need to create logarithmic models for these types of data. Okay? So our function models. What we already know about logs and what we have looked at from data tables, right? For a given set of data, the input values appear to change proportionally over equal length output value intervals. Then it's logarithmic. Now remember, when we're working with real live data, it may not be exactly doubling every time, but roughly doubling every time, then that's the model that we would go with, that type of thing. Okay, so a logarithmic function model is in this form here, where it could be a natural log or a common log, where a and b are constants. B can't be 0 because then it wouldn't have a log in it. Okay, we good with that? Some of these we're going to do by hand. Some of them are going to be done on the calculator. We're going to do this one, kind of both, but starting out with just by hand part here. So selected values of logarithmic function L are given in the data table above, and then it gives me how to set it up, right? Use the given data to write two equations that can be used to find the values for constants a and b in the expression for L of x. You had a question similar to this on your last review. I didn't ask you to find a and b. I just asked you to set it up because that is something you should totally be able to do. You have two ordered pairs, 2, 3, and 5, 7. Okay, so we're going to put these in here. I have that L of x right there. My first y value is 3. So 3 is equal to a plus b, because we don't know what they are, times the natural log of that x value, which is 2. My other equation would be the y value of 7 equals a plus b times the natural log of 5. That's all that first part is asking you to do. You literally just put it in there, okay? Then, now we're going to find the values of a and b. In order to do that, I have 2 equations and 2 variables. What is this type of situation called? A what of what? A what of equations? System. A system of equations. And we have multiple ways to solve systems. If I had 3 variables, I'd need 3 equations. We can use matrices. We can use substitution, elimination, graphing. But since this is non-calculator, I think the substitution or elimination is probably what most of you would go to. I think most people are more comfortable with substitution, but sometimes things just present themselves in such a way that elimination makes a whole lot of sense, right? So I would definitely go with elimination on this one. Paulina, you here? Thanks for being such an awesome map. All right, so I would say on this one, elimination looks pretty good. Would you agree with me on that? So I'm going to just rewrite this first equation right here. 3 equals a plus b times the natural log of 2. So if I want to eliminate something when I combine them vertically, then I think a would be the easiest thing to eliminate. Would you agree? So I need a to be negative, so I'm going to multiply through by a negative on all of them. So negative 7 equals negative a minus b times the natural log of 5. Okay? Then I just combine them. Gives me negative 4 equals, those zero out. Then I'll have b times the natural log of 2 minus b times the natural log of 5. What am I solving for here? B. So what would I do next? How am I going to get b by itself? What have we done in other situations like this? Okay, well, I can't join these two because they're not the same log. It's like log of x and log of y, so it's kind of like having 2 different variables, right? So that's not, if they were both log of 2, yes, I could totally do that, or something else like that. What's another option? If I cannot combine those 2 terms. How do I get b by itself? We've done this in other things we've solved here in the last week or so, actually. Do what? I can't do that because unless I make that b an exponent, I see what you're saying. Since I'm subtracting, I could do that if I wanted to make b the exponent and I could combine them. I could do that. So that is definitely a possibility. But since I'm trying to get b by itself, I really don't want to put it in the exponent, although that would work. Give me another option. Something that you've known how to do for years. Factor it out. Very good. Okay, and that's something, guys, I know y'all know how to do it, but every time it comes up, it's like crickets, okay? And that's not a good thing. So we got to remember what to do there, okay? But here's what it worked. So negative 4 is equal to b times the natural log of 2 minus the natural log of 5. Now, at this point, I could put them together if I wanted to. Does that make sense? That would help. But I don't necessarily need to. So I can combine them, but I don't necessarily have to because I'm solving. So I think I'm just going to not do it, even though it's not wrong, just because I don't want to have to do extra things that I might mess up. But now what can I do to get b by itself? Divide. Okay, so negative 4 divided by the natural log of 2 minus the natural log of 5 equals b. Everybody okay with that so far? All right, so let's say that at this point, we're not just yet, but we will put that in a calculator in just a minute. So bless you, B is B, right? That's going to be some value that I get out of the calculator. I'm also going to need A. So I can use either one of these. It doesn't matter. I'm going to use this first one, bless you, and I'm just going to solve it for A. So I'm just going to rewrite it. 3 equals A plus B times the natural log of 2. Okay? Everybody okay with that? To get A by itself, all I have to do is subtract, right? So 3 minus B times the natural log of 2 equals A. Do y'all agree with those? Okay, so let me show you why I'm doing it that way and I'm not substituting it in yet. Because if this is one where I'm going to go and get the numbers out of the calculator, which I am in just a minute, I want you to see that this B, which is this B right here. And we're going to find this one first. Okay, so let's go to the calculator. We're going to do, let's just get a whole new thing so we don't mess anything up. New, no. We're going to add a calculator. I want to start with a fraction so I don't mess up parentheses anywhere. And I have -4 divided by natural log of 2 minus natural log of 5. Natural log of 2 minus the natural log of 5. Okay. And then I'm going to write down what? 4.365. So B is equal to 4.365. Would I ever in a million years type that back into my calculator? No. Okay, but that is B here. But I'm not typing it in there. This is what I'm going to do. I'm going to do 3 minus that mess up there. So I can arrow up and hit, and when it's highlighted, hit enter, and it puts it right there. It actually is storing more decimal places than you can see. Times the natural log of what? 2? 2. And then there's my other one. -0.025. A equals -0.025. There are times when I might need to actually store it so I could go back and use it differently. You can store it, but I don't need to because I can just arrow back up and grab it. Okay? We okay with that? What questions you got? Okay. Let's flip this over. Now this one says, the table above gives the data from the graph at the beginning of the notes related to church size and average salaries for pastors in the United States. Use the regression capabilities of your graphing calculator. Okay? So we're going to use our regression capabilities. Usually when you, what I've seen anyway, I say usually, but I haven't seen that many. If they just give you 2 like what was on the front, it lends itself more towards a non-calculator question, where this lends itself more towards a calculator question. That's why I had you solve the other one that way. But we're going to put this mess in the calculator. So if I'm going to do regression on my calculator, let's go on again. 1 for new, no. What am I adding? Lists and spreadsheets, right? 4. Go up here, you can call this X, and then type in your X's, and then type in your Y's. All right, so while you're typing, let's go back and look at this. It says to find the logarithmic function model for the data above in this form right here, where P represents the church size and S is the average pastor salary in thousands of dollars. All right, so when I go back over here, what do I do to get what they just asked me for? What buttons do I push? Menu, then what? Statistics, stat calculations, and then which regression do I want? Not everything is linear. That seems to be, let's do 4. No, it's not a line. Okay? What am I looking for? Logarithmic. Do you see it right now? No. So if we arrow down, it's the next one that you can't speak. Logarithmic regression. We hit enter. Then we do the same thing we did before. So choose X, choose Y. That's why it's easiest just call them X and Y and not get fancy, so you can put them in the right spots. Okay, so when I do that, I don't see right now what I expected to see, but that's because I'm scrolled down to row 7, right? So if I scroll back up, then I can actually see that it's A plus B. It tells me what form it's in, so I know where A and B go. If you need to see more decimal places, you can click on them or hover over them to see what A and B is. But that's where we get our equation from. So then we're going to say, all right, that means that S of P is equal to negative 91.542 plus 29.908 times the natural log of P. Am I ever going to go type that in anywhere? No. Did the calculator take care of that for me? Where is this? Where's this equation? F1. If you got to make yourself a little note out to the side saying, that's F1, dummy, don't mess this up, then do that. All right? Like, I wouldn't put it like in the answer, but if you write extra random stuff like that down, it's fine. You're reminding yourself it's in F1, right? No rounding. You just truncate. You can't, rounding is acceptable. I don't want y'all to round because I'm afraid some of y'all are going to mess that up. So just get in the habit of truncating and you're fine. It's totally legal. Okay, we good on that? Now, that's not to say if it was a multiple choice question, maybe it would be rounded, but I think you'd be able to tell that and you'd be fine. Okay, good question. Anything else? Okay. So then it says, using the model found in part A, okay, but in part A, it's really in F1, right? What is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people? So 500, is 500 the X value or the Y value? Or is it S or is it P? Like how you want? It's the X value, right? So we're looking for S of 500. If I want to find S of 500 on my calculator, what screen do I need? Calculator. So I'm going to control, add a page, add my calculator, and where is this stored? F1. So I can type, I don't have to worry about looking for variables, just F1 of 500. I don't even have to look at the graph, right? There it is. 94.329. So I'm going to put 94.329 what? Is it just dollars? Thousands of dollars. It is the average salary in thousands of dollars. Be very careful not to put in a situation like this just dollars or something like that. It's thousands of dollars. Now, what if I had said, if a pastor has an average salary of $94,000, what would be the average size of his church? Like, what if I gave you the Y and I wanted the X? What screen would I go to for that? That I need the graph. If I give you the Y, and so this is a log, right? So we're thinking it looks like something like that, right? And then, so if I give you that and I say, what is the, if the salary is 94 or whatever, you would put in 94 for the F2, and then you look to see where they intersect to find that X value, okay? So X value is just S of, you go to the calculator. If they give you the Y value, want the X value, that's when you have to go to the graph, right? Remember doing those? We're just trying to keep it all fresh in our little brains. All right, any questions about those? Great. Now, this is non-calculator, so we're not going to touch the calculator for the rest of this. The most common and preferred method to measure sound intensity levels is in decibels. The sound intensity level beta in decibels of a sound having intensity I in watts per meter squared is modeled by this function right here, okay? Which is a log function. This is a common log, not a natural log, okay? The sounds of noisy traffic has intensity of 1 times 10 to the negative 5th watts per meter squared and corresponds to 70 decibels. A loud concert has intensity of 1 and corresponds to 120 decibels. So we're going to use the given data to write 2 equations again that can be used to find A and B. So before I do that, I want to make sure I know what my ordered pairs are. They gave me information to fill in 2 ordered pairs so I can write 2 equations. I know that this 1 times 10 to the negative 5th goes with 70. But I got to make sure I know which one's x and which one's y. Okay? Which one of these 2 things are my x value? What is my input? What is my output? What is my input and what is my, just in general, what's the input? The watts. B of I is your input, right? Your I is in, I'm marking that up. I is in watts per meter squared, so it's the intensity that is the input. The decibels are the output, okay? So that means that this x value is 1 times 10 to the negative 5th, and y value 70. What is the other ordered pair going to be? 1, 120. Everybody okay with that? You understand how to figure out what's what? And I mean, I know you're not decibel experts, neither am I, but we can get through this question here, okay? Plus, I know the fact that it has scientific notation there, gives you the chills or something, but you'll be fine. So we're going to use the given data to write 2 equations. So I'm going to start with the first ordered pair. My y value, the output, is 70. That's equal to A plus B times the log of 1 times 10 to the negative 5th power. And then my other one is going to be 120 equals A plus B times the log of 1. First step, 0 work, you substitute it in. Even if your little wheels are already turning and you know how to simplify this, great, we're going to get there. Do not do that in the first step. That is not what they want. They want to see you substituting it in so that you have something to find for A and B. You with me on that? Okay, now let's try and simplify this for our brains a little bit. 1 times 10 to the negative 5th. Do I actually need that 1 there? Isn't 1 times 10 to the negative 5th just 10 to the negative 5th? Would you agree with that? Okay. So I left it in there like that because it's exactly what they gave me. But now let me think about what that means for my log. And you could rewrite the whole thing if you want, and you don't necessarily have to rewrite anything, but I'm just going to write it over here so you can see what I'm saying. If I have the log of, and I don't need that 1, it's just 10 to the negative 5th power. What's the base on this log? 10. And so it doesn't have to be there, but if I have log base 10 of 10 to the negative 5th, what does that give me? Negative 5, right? So when I rewrite this one, I'm going to rewrite it right here. I'm going to get 70 equals A, and then this whole thing became negative 5. That's going to be minus 5B. See how that works? And if you need to write down more to get there, you can. There's not a lot of space here, so you'll have plenty of space to write on the actual test. All right, so then the next one, I've got 120 equals A plus B times the log of 1. What's the log of 1? 0. So this whole term just zeroes out. So I get 120 equals A. See how easy it was to solve for A? So now when I want to solve for B, I'm going to get 70 equals 120 minus 5B. So that's negative 50 equals negative 5B, and B equals 10. Okay? And all it asked us to do was find A and B. That's what we did. It asked us to set them up. Then it asked us to find it. If it took you more steps to write all that stuff, that's totally fine, but so there wasn't a whole lot of space. Before we move on, let's take a little brain break for a fun fact. The word decibel comes from 2 pieces. Deci, which means 10, right? Decimeter. decimal, refers to the fact that the level of sound found is multiplied by 10 as part of the formula. So deci is 10. Bell refers to Alexander Graham Bell, the inventor of the telephone, and the person decibels are named for. So Alexander Graham. So there you go. That's what a decibel is. All right. Now this says the human eardrum can burst when its sounds reach an intensity level of 1 × 10⁴ watts per meter squared. According to the model found above, what is the predicted number of decibels required to burst a human eardrum? All right, so we have beta of I equals A, which is 120, plus 10 times, just 10 times the log of I. Right? That's what our equation is once we found A and B. Everybody okay with that? This is asking us to find beta of 1 × 10⁴. That's equal to 120 plus 10 times the log of 1 × 10⁴. All right, so we'll rewrite 120. What is the log of 1 × 10⁴ power? 4. So that is 120 plus 10 times 4, and that's going to give me 160 what? Decibels, right? 160 decibels. So you can write out the word, or they did give us the symbol up here, just little d, capital B, so we can say decibels, or you can write out the word. It doesn't matter. All right. What questions do you have? So do you see you have to understand how to do things by hand and also how to use all the different things you need on the calculator. Okay? Any questions at all? Awesome.